Okay, guys, this is the fourth day. We're covering a lot. We're going to convert these following decimals to fractions, and the trick is to know your place values on decimals. So we know that this first place value after the decimal is called the tenths place value. Then this one's the hundredths, and this one's the thousandths. Then you got the 10,000ths, and so on and so on. Okay, so if I do give you the decimal 0.123, how do you convert it to a fraction? You just read it 123 and you over 1,000, right? And another way of looking at this, like let's say I did this. Let's say I said convert 0.5731 into a fraction. Then you could just put the 5731 over 1 with how many zeros? Well, you have 1, 2, 3, 4 numbers, so 4 zeros. Simple as that. All right. So converting a decimal to a fraction, it's really easy. Just remember that it's all based on your place values, or you could just put the 1 with however many zeros of those digits you actually have. Okay. So let's go to our actual practice right here. Pick one. 17. All right. So what number are we going to write on the top of this fraction? 137. Over, let's put a 1 with how many zeros?
4.
We have 1, 2, 3, 4, right? So yeah, 4 zeros. 1, 2, 3, 4. So there it is. It's 137 over 10,000, and we're done, right? So all these are pretty easy. Number 11, what's number 11 going to be as a fraction? 13 over 1 with 2 zeros, because there's 2 numbers right there. Or you could think of it as tenths, hundredths. So yeah, 13 hundredths. Number 14, how am I going to write that as a fraction?
Number 13?
14. 12 over 100. That's right. Now, keep in mind, guys, whenever you create a fraction, if you could reduce it, you better reduce, right?
Yeah.
So right here, they're both even numbers. 12 and 100 are both divisible by 2. Or you could take a couple of seconds longer if you know your multiplication tables and think, is there a bigger number that both of them are divisible by? Okay, if you're able to, you could see that they're both divisible by 4, which would give you the final answer 3 over 25. Right? The final answer is 3 over 25. But let's say you didn't know that they were both divisible by 4. Then you could just simply divide by 2.
And then you do it.
And you do it again. Right? So this becomes 6 over 50. And then you divide by 2 again. Divide by 2. Divide by 2. And you get your final answer 3 over 25. Now, if you knew your multiplication tables really well, you'd see that you could divide both by 4. 12 divided by 4 is 3. 100 divided by 4 is 25. But if not, you could always just divide by 2 or by 3. The way we did here to get the right answer. So I want to pause it right here. I want to make sure that everybody gets all of these done right now. Go for it. I'll show you the answers in a couple of seconds. If you're watching this at home for the first time, please pause it and try to do the rest. So here are the answers. I hope everybody understands how I got these answers. Again, the decimal, all you got to do is convert it to a fraction, but try to reduce your fraction. So if we zoom in on number 10, the 0.2 is going to become a 2 over 10. It's in the tenths position. And then reduced by 2, you get 1/5. Right? This 5, it's really over 1 with 2 zeros. So it's 5 over 100. Right here, you're going to reduce by 5. So you always have to reduce. Okay? 16 is interesting. You have the number 2 over a 1 with 1, 2, 3 zeros. So 2 over 1,000 reduced by 2, you get 1 over 500. You're going to have to do this on your own on the quiz Friday. So please make sure you understand this. If you don't, if you're struggling, watch the video again so you could get a better understanding of it. Or stop by my class in the morning. I'm always here at least 15 minutes before the bell rings. 25 over 1 with 1, 2 zeros. So 25 over 100. That one's pretty easy. It's like having a quarter over a dollar, which is a quarter over 4 quarters. 1 over 4. This one's 88 over 1 with 1, 2, 3 zeros. 88 over 1 with 1, 2, 3 zeros. You could reduce that. Now notice, even though I know my multiplication tables, I ended up just dividing by 2. Right? I took the 88, divided it in half, I got 44. Took the 1,000, divided it in half, I got 500. And then 44 over 500, I divided it in half again. So that's really 22 over 250. And then I divided it in half again, which gave me 11 over 125. I can't divide 11 by 2 or by 3. That's as far as I could go. That's my answer. 18, it's 777 over 1,000, and there is nothing to reduce. Let's move on to this next section, converting following decimals to percents. Okay, so I hope we remember how to convert a percent to a decimal, right? Like if I told you you're giving 100%, if I'm a coach, I'm your coach, and you're giving 100%, that's good, you're giving 100%. What does that mean? You're trying all you got, all of you, right? Okay, not a part of you, not half of you, you're talking about all of you. So when you're talking about 100%, there's really an invisible decimal right here, and if you move it over to this way, you end up with the decimal 1.00, right? So 100% means one whole. So you could always think of that to get the understanding of how to convert percents to decimals, or backwards from a decimal to a percent. So if I told you, here's a decimal, 0.25, and I told you convert it back to a percent, which way are you going to move it? To the right. 1, 2, and that becomes 25%. Now that makes total sense, right? Because 0.25, that's nowhere near one whole. 0.25 is technically 1/4. It's nowhere near one whole. It's not even 1/2. So when I say 0.25, what does that mean as a percent? It's only 25%. 0.25 of a gas tank is only 25% filled of a gas tank. That's not even half. Make sense? Okay. Now what if I said convert 0.99 as a decimal? As a percent. It is a decimal, change it to a percent. That's almost one whole. That's almost one whole. So what percent's going to be? 99%. It's almost 100%. Okay? So just think about that 100% and which way you move it, because 100% means one whole. You're giving it all you got. 100% means all you got, one whole. Okay? So let's go over here and let's convert these decimals to percents. So if it's a decimal, I need to convert it to a percent. Now let's think about this. This is 0.2. Is that close to one whole? Not really. It's closer to 0 than 1, right? Okay. So if I convert it to a percent, which way am I going to move the decimal? So what do I end up with? 2 with this extra 0. So that's 20%. 20% is hardly anything, right? It's pretty close to nothing. So you're just moving the decimal over 2 to the right when you're going from a decimal to a percent. Now if you're going backwards from a percent to a decimal, you're going to be moving to the left. Okay, so that's kind of tricky, but just think about that. That 100% means that you're giving one whole, the whole effort, 100%. All right, so how about 13 as a percent? What's that going to be? 13%. How about 0.25 as a percent? 25%.
What about number 34?
Number 34. Oh, we're already going to percents back to decimals? Because right here, from here we're doing through 27. As a matter of fact, I would like you guys, I want to pause it right now. If you're at home watching this for the first time, hit pause, try to do the rest.
25.
Okay, so before I give you the time, let's look at number 25. What's the rule here? How do you convert a decimal to a percent? You move it 2 spaces to the right. So you're going to move it from here, 1, 2, and your decimal's right there in front of the 2. So you really have 0.2%. That's like hardly nothing. That's not even 1%, right? And those numbers actually exist. Like, there's studies, let's just say, what's the percentage of students that have gotten suspended and then, I don't know, whatever, and it could be a really, really minute amount of population. So 0.2% is not even a percent, right? Not even a percent of the population. Okay. So go ahead and do the rest. I'll hit pause and then I'll show you the answers in a couple of seconds. So here are the answers. Just move the decimal 2 to the right and then put a percent on it and you're good, right? Oh, wait a minute. I made a mistake. Which one did I make a mistake on? 22? I made a mistake on 22? No, not 22, but there is a mistake. Which one is it?
24.
24 is a mistake, right? I'm supposed to move this decimal 2 spaces over. 1 in front of the 4, 2 in front of the 7, between the 4 and the 7. So it should have been 4.75, 4.75, not 47.5, 4.75%. Now, believe it or not, when I bought my house, the actual interest rate that I got on my house was 4.75%. So, I mean, those percents really do exist out there.
What is interest rate?
Interest rate is, let me pause this. Let's go to this next one. Convert the following percents to decimals. Okay, so just like we mentioned before, let me go over here to the side. A percent to a decimal, if you're giving 100%, what does that mean? You're giving all that you got. You're giving one whole, all of yourself, right? One whole. So what does that mean? From percent to a decimal, you move it this way. So that'll be a 1, right? So let's go back and just start moving them 2 spaces to the left instead of to the right. So 28.3, what's that going to be? 0.03. Or you could put a 0 in the front, 0.03. Either way, you still move it from here 2 spaces over, which you need a 0 right there. So 0.03. This one's going to be what? 0.07. The 150 is going to be what? 1.5, right? Or 1.50. Now, I know that's kind of weird, 150%. You can't really give 150%, but what that really means is 100% and then 50% more. So that's 1.5, right? All you got to do is move it 2 spaces this way. Okay, do the rest. Hit pause if you're watching this for the first time at home, and I'll show you the answers in a couple of seconds. So check your answers. This will be on the quiz Friday. And now for the final section of this. Any questions on this? On 28 through 36? No? Even 34, it was here as a percent. You want to change it to a decimal, move it 2 spaces to the left. 1, 2, you got to put an extra 0 right here with the decimal in the front. So that's really 1, 0, 2, 0, 3 zeros before the 6. 1, 2, 3 before the 6. And of course, if you wanted to, you could put a 0 out in front of the decimal because obviously there is no number out there. Let's convert the following fractions to decimals, then to percents. So the fraction to a decimal, well, you're going to have to divide, right? If you have a calculator.
And then it'll be 0.25 and 1 2 10 to the right will be 25%.
There you go, 0.25. If you divide 1 by 4, you'd have to put a decimal, make it look like a 10. You'd have the decimal up here, you would say 4 times 2, so that'd be 8, right? And you'd get a remainder of 2, add a 0, drop a 0, so that'd be a 5. That's 0.25. So this is correct. 0.25 is the correct decimal for the fraction 1/4. And then they want us to convert that to a what? A percent. So all you got to do is move it 2 spaces over, and you'll have what as a percent? 25%. There you go. Easy peasy. 7/10. How could we convert that to a decimal? You could divide or just listen to it. 7/10. That's 0.7, right? In the 10th position. So that's really 0.7. Remember, this is the 10th position. So you read this as 7/10. You read this as 7/10 as well. Okay. If you wanted to, you could have put the 7 inside of the division box, the 10 on the outside, put a 0.0 on the 7, make it look like 70, and do the division. But this is your answer. And change it to a percent now. What's that going to be? 70%. All right. 39. Well, even before converting to a decimal, what should you always try to do with any fraction? Simplify, reduce. What are we going to reduce this by? By 6? All right. That's good. You guys didn't just say 2. You could have gone 2 and then 2 again and 2 again, but you could go by 6. 24 divided by 6 is 4. 30 divided by 6 is 5. There is your fraction, 4/5, right? If you want to convert that to a decimal, let's... What? 0.8. You are absolutely right. You see, 4/5 could be changed to 8/10, which would be 0.8. Let's just do the division so nobody gets lost here. We're going to take that 4, we're going to divide it by the 5, put a 0.0 on it so it looks like a 40, and then you're going to say 5 times what is 40? 5 times 8 is 40. This decimal just comes right up, and you put it right there in front of the 8. So 4/5 is really 0.8. And then now to a percent, you move it 2 spaces over, that'll become 80%. 9/10. Convert that to a decimal. 0.9. If you just listen to it, 9/10. This is in the tenths position. You read it the same way, 9/10. Okay, and as a percent? 90%. All right. This last one, 7, or not last one, but close to it. 7/100ths.
0.07.
Yeah, if you listen to it, the 0. This is the tenths, this is the hundredths. So 0.07, that's read the same way, 7/100ths. As a percent, what would that be? 7%. Okay.
0.52.
Number 41?
Yeah.
0.52?
Yeah.
Okay. Do we have a process for it? Or any tricks we could use on number 41? How about this trick? Since I know I'm going to eventually get it to a percent, and I see that this is 25, I could make it look like 100, right? By multiplying by 4.
Oh, yeah, sure.
So that way it'll be 100 on the bottom, and up on top it'll be 4 times 10 is 40, 4 times 3 is 12, so that'd be 52, right?
Yes.
So I already know that the fraction 52 over 100 is the percent, 52%. So I already have my percent answer. I still need my decimal answer. And because it's with 100 on the bottom, if you read that, it reads 52 hundredths. So you could write that as 52 hundredths, 0.52. Why? Because this is in the hundredths position. Tenths, hundredths, 52 hundredths. So that's just a little trick. You could have divided 13 by 25, and you would still get the answer 0.52, and you could convert that to a percent. Okay, we could use that same trick on 42. So what percent is this going to be if you change this to 100?
0.8.
It's going to be 18%, right? So if you were to change this by multiplying both top and bottom by 2, you'll get 18 over 100, which as a decimal is going to be 18 hundredths, 0.18, and as a percent it's going to be 18%. Fraction, decimal, percent. 5/9. This one is where it gets weird, all right? It's a repeating decimal, exactly. Anybody know the repeating decimal?
Put a line on top.
Yeah, you put a line on top. So let's toy with this, right? Here's a fraction. Let's say 5 divided by 9 and put a 0.0 to make it look like 50. And then you could say 9 times what gets us close to 50? 9 times 5. Sorry, 9 times 5 gets us close to 50. That's 45. When you subtract, you get the remainder of 5. You add a 0, drop a 0. And then you're going to put another 5. 9 times 5 will get us close to 50 again. You'll have 45. Subtract, you get the remainder of 5. Then you add a 0, drop a 0. And what's going to happen? It's going to keep going forever and ever and ever. So it's really 0.55, but that 5 keeps repeating. So this is your decimal, 0.55, and it repeats. It's not irrational because it has a pattern. It's repeating the 5, which means you have a nice fraction, and we all understand what 5/9 means. If you wanted to write it as a percent, you would have to move your decimal over 2 places. So you have 0.5555, and it keeps going. But if you move it over 2 spaces, that'll be a 55%, but then with a 0.5, 555, like that. Or you could do approximately 56%, because the 5 will make it round up to a 6. I would leave it like this though, 55.55 with the percent on it. Last task, we have all these different real numbers. We have natural numbers, integers, we have irrational numbers, irrational, integers, rational, and they want us to write them in order from least to greatest. And the best way to do this is to write a number line and see which one's further left, further right. That way you know which one's the least one and which one's the greatest one. So let's go with the easy ones first. Let's say 0's right here, which means that 4 is going to be way over here in the positives. -3 is going to be way over here. -2 is going to be right here. So we've got the 4, the -3, the -2. Where would -3.25 be at? This guy.
In the middle?
In the middle of what?
Oh, no. In front of the 3.
Yeah, it'd be to the left of the negative 3, right? So let's put that dot right here, put negative 3.25. Okay, what else? Where would this guy be at? The negative 7 over 2. What does that really mean? What's 7 over 2? What's 7 divided by 2? I mean, it's not a nice number, but you could convert it to a decimal.
3.5.
3.5, so negative 3.5, right? This is really a negative 3.5. Where would that be at?
Yeah.
Even to the left, right here, yeah. This is negative 3.5. Yeah, to the left. Yeah. Okay, what else do we got here? We got two radicals to deal with. Could anybody give me a decimal approximation for the square root of 10? Is it like, is it 5? Is it 6? Is it 2? 3? What do you think? 3 point. Okay, so the square root of 10 is between what perfect square numbers? The square root of 9 and the square root of 16. Which one is it close to? The square root of 9. So your answer is going to be close to the answer of the square root of 9. What's the answer to the square root of 9? 3. So you're talking about 3.1, 3.2, right? That's probably a bad one to do because that ends up being right here. Maybe we should just eliminate that one. But 17, where would 17 be at? Let's do approximation right there. The square root of 17. Give me a decimal approximation. Come on, guys. Where's the square root of 17 at? 4.1, right? If you know that the square root of 16 is 4, the square root of 17 is going to be a little bit more. It's going to be about 4.1. So 4.1 would be out here. The square root of 17 would be out there. So let's list from least to greatest. We have the negative 7/2. That's going to be the first one. That's the first one. That's the least one. And then the negative 3.25. That's the next one. And then we have the negative 3. Then we have the negative 2. Then we have the 0 wasn't even on the list, but we do have 4. Then we have the square root of 17. So there it is in order from least to greatest. Let's just eliminate that square root of negative 10. That one is kind of confusing. And that's about it, guys. I think I might give you one of these as an extra credit question on the quiz for Friday.